Imagine that we have something like the log base 2 of 16. Hopefully this shouldn't take you too long to figure out that that is 4, because 2 to the 4th is 16. And another way we could have written this original question, the log base 2 of 16, is the log base 2 of 16 is 2 to the 4th. The log base 2 of 2 to the 4th is 4. Then in the same way, the log base 3 of 3 to the 7th must be 7. And the log base 10 of 10 to the negative 5.3 is going to be negative 5.3. And the natural log of e to the 73rd is 73. We might even think of this as a new rule for logarithms, that the log base anything, base, we'll just call it b, b might be 2, it might be 3, it might be 10, it might be e, it might be anything we choose, of that same base, b, to some power, we'll just call that power k, is equal to k. Now, this isn't really a new rule, because really it falls out from the fact that an exponential function and a logarithm are inverse functions of each other. Remember, what that means is the output of one becomes the input of the other, and when you put that output from the first function in as the input of the second function, you get your original input back. And so here we said, I'm going to take a 4 and I'm going to make it the input into the exponential function 2 to the x. And then what I get out of that, 16, becomes the input into the logarithm function, log base 2. Well, then I darn well better get the 4 back out, because that's what an inverse function does. And that's all that this is really saying. So I'll write it down as a new rule, but all this is really saying is the logarithm is the inverse of the exponential function. This one, I think most people have a pretty good handle on, but the one that looks weirder and is still just as true is if we do these two functions in the opposite order. Say we started with whatever the log of, say, 3 is, log base 10 of 3. That's some number, some decimal number. And I take 10 to that power. What is that? Well, let's take this. I've got 10 to the something equals x. This is an exponential function. 10 to the blank equals x. That could be rewritten as the log base 10 of x equals blank, equals whatever the exponent is. And the exponent in this case is the log of 3. But rule number 3 over here says if you've got two logarithms with the same base that are equal to each other, then the arguments inside the logarithms, the things we're taking the logarithm of, must also be equal. So if the log of x equals the log of 3, then x equals 3. So 10 to the log base 10 of 3 is 3. In the same way, we could say that the natural log, e to the, and then up in the exponent, natural log of 7, that's going to be 7. 2 to the log base 2 of 1/3. That's going to be 1/3. And so I'm still going to lump this in here with rule number 5. You might think of this as rule 5a, and here's rule 5b. This says if I've got some number b, and I raise it to a power, and up in that power is the log base b of some number, say k, that's equal to k. This, again, is really just saying logarithms and exponentials are inverse functions. They undo each other. When you do a logarithm and then you do the exponential of that, those two things cancel out. Put cancel in quotes there. And so what we end up with then, I'm going to copy all of this over to a new slide. So let's copy this, get a new slide and paste it. Okay. What this means then, if I see something like 10 to the 2 times the log of 6, this is not 6 because of this 2 out front, if this whole thing's up in the exponent. But rule number 4 here says that 2 that's being multiplied by a logarithm, that 2 that's a coefficient, according to rule number 4, this is the same as writing 10 to the log of 6 squared. Which is 10 to the log of 36. And so then we can use rule 5b and say, hey, 10 to the log base 10 of 36, that's just 36. So let's do something similar here, where we say, I'm going to do 5 to the 2 plus 3 times the log of x. And I just want to simplify this. This looks kind of yucky. This looks kind of ugly. I'm just going to simplify this. Well, we're going to mix some rules of exponents and some rules of logarithms here. One thing we might do is we might use rule number 4 for logarithms. Just to look at this, rule number 4, I've got 3 times the log of x. That means this whole thing becomes 5 to the 2 plus. That 3 becomes an exponent inside the logarithm, the log of x to the 3rd. Sorry, I left a base off my logarithm. I want this to be the log base 5 of x. My mistake. This only works if the logarithm's going to be the same base here. Okay, so I apologize for that. 5 to the 2 plus the log base 5 of x cubed. Well, let's look at this. I've got addition up in the exponent. When do we add exponents? We add exponents when we are multiplying two things that have the same base. 5 to the 2 multiplied by 5 to the log base 5 of x cubed. Since I'm multiplying these, I would add the exponents, so we can go the other direction too. If we've got addition in the exponent, we can break it apart into two things multiplied together. But now, this 5 to the 2 right there, that's just 25. And rule 5b here says that this right here, 5 to the log base 5 of x cubed, is just x cubed. And so 5 to the 2 plus 3 times the log of log base 5 of x, that's just 25x cubed. This is the simplified version of that.